Hey everyone, hope you're doing well today. In this video, let's just go over a few practice problems dealing with rates. So this is just going to be a little answer key or just like a little tutorial going over a few different examples, just to help you feel a little bit more comfortable with these rates. So for number one, we're going to go ahead and write the following as a rate. Then we're going to go ahead and write two equivalent rates, one that uses larger numbers and one that uses smaller numbers. Make sure we're going to show our work here. Okay, so we see that Miss Jager is going to be eating 36 waffles in 26 minutes. So I'm going to go ahead and put waffles on top, and I'm going to put minutes on bottom. Okay, so for the first ratio or rate here, I'm going to write 36 waffles in 24 minutes. And one of the directions says that we have to use larger numbers. So to do that, I'm just going to go ahead and multiply this top number by 2. So you can multiply them both by any number to get larger numbers. And to get large numbers here, we'll get 72, and we'll have 24 on bottom. So this is the one rate that's equivalent, that's using larger numbers. And for using the one with smaller numbers, let's go ahead and say, okay, let's take that original ratio of 36 and 24. And to get smaller numbers, we just have to divide by something that they both are divisible by. So I know 4 is a common factor of both of these, so I'm going to choose 4 just to keep whole numbers here. And we'll have 9 on top and 6 on bottom. So these are two equivalent rates, 72 waffles in 48 minutes and 9 waffles in 6 minutes. So these are both solutions that are equivalent, okay? For number 2, it says, write this as a rate, then determine the unit price. Make sure we show our work. Okay, so we're going to show this as a rate. So typically when you're dealing with money, that's going to go on top. So it's going to cost $24.66. And we're buying 9 pens. So I'm going to put that 9 on bottom. It says find it as a unit price. So unit price is per 1 pen. So how do we get from 9 pens to 1 pen? Well, we're going to go ahead and divide by 9. And if we do the bottom, we got to do it to the top because that's how we write equivalent rates and equivalent ratios. If we do 24.66 divided by 9, I can do that work on the side here. Just to review, if you need a little bit of help with dividing decimals, it's just like the normal standard algorithm. So dividing by 9, bring the decimal straight up. 9 doesn't fit into 2, but it fits into 24 2 times. 2 times 9 is 18. We subtract, we're going to get a remainder of 6. Bring down the 6 to make it 66. We'll do 7 times 9, that's 63. The remainder here is 3. And then bring down this last 6. So 9 goes into 36 4 times. 4 times 9 is 36. So we have a remainder here of 0. So what we just found out here is that for 1 pen, it's going to cost $2.74. So we're going to say it's going to cost $2.74 per pen. All right, that would be the solution here as the unit rate. Okay, the unit price is just telling us, or asking us rather, in this problem, what is the cost of 1 pen? All right, so that's 1 and 2. For number 3, let's go ahead and take a peek at this. We have here 3 identical ice cream cones cost $5.31 in total. We're going to fill in the rate table and then graph the relationship. Okay, so we see here that the given information is that $5.31, that's for 3 of these ice cream cones. So take a look where it says 3 ice cream cones. So we're going to go ahead and put $5.31 over here. Okay, and what we typically like to do is find the unit price first. So what we can do is we can divide this by 3, right? 3 divided by 3 is 1 cone. And if you take $5.31 and divide it by 3, I believe that's going to be $1.77. Okay, and why it's so important to find out the unit rate or unit price first is because now that we know what 1 cone costs, we can pretty much figure out what all of them are going to cost. So how does 1 become 5? Well, that's just times 5, right? So if we go ahead and take that 177 and multiply it by 5, or take this 177 here and say times 5, then we know this price here is going to be $8.85 for 5 cones. And you could go from 1 cone and multiply by 10 to get 10 cones, but I'm noticing here that we can actually just double 5 to become 10, so that's just times 2. And that means over here we can just double this $8.85 as well, and then we can get $17.70, okay? For this last one here, again, you can go from different types of ones. That's all perfectly fine. I think what I'm going to do personally, though, is I'm going to say, oh, I know 3 times 4 gets you 12. So if I know I take this 531, that's right over here, 531, and multiply that by 4, then I should get the total price for 12 of these ice cream cones. I think that's going to be $21.24. Okay, so again, as you buy more ice cream cones, it should cost more money. Now for labeling the graph over here to the right, keep in mind that this is the independent variable and this is the dependent variable. So the cones, the number of cones is going to go across the x-axis as the independent variables. Here's the y-axis going up and down. And what we have here is that's going to be representing the total cost. So I'm going to write total cost, and that's going to be of all the ice cream cones. The origin here is going to be 0. Let's see here. We have 1 cone, 2 cones, 3, 4, 5, 6. I know I have 12 boxes from the beginning, so if you were doing this and you weren't sure, you should probably count them first. 10, 11, 12. I just happen to already know. And then going up the y-axis here, to make this easier, maybe just go by $1.77, right? Then we should not have to do too much work. So if we do $1.77 times 2, that's going to be $3.54. But what's another $1.77 on top of that? I think we already know that's $5.31. $5.31. I think I'm going to run out of space here, so let me just move this over a little bit. If I add another $1.77 onto that, that should be $7.08. Okay. If I add another $1.77 onto that, so I know it's a little strange maybe, but we're going by multiples of $5.77. Okay. Adding another $1.77 onto that, that's going to be $10.62. Adding another $1.77 onto that, that's going to be $12.39. $12.39. Adding up another $1.77 onto that, we're going to get $14.16. Another $1.77 on top of that, that's going to be $15.93. Another $1.77, that's going to be $17.70. That should look familiar. Plus $1.77, that's going to be $19.47. And finally, at the top here, we're going to have $21.24. Okay, so the next step we're going to do is go ahead and graph it. So 1 ice cream cone we know is going to cost $1.77. That's on the table. 3 ice cream cones is going to be $5.31. So go to 3 cones on the x-axis up to $5.31 on the y-axis. 5 cones along the x-axis, we got to go up to $8.85 along the y. Then we got to skip all the way over to 10 ice cream cones. That's going to be $17.70, which is right up here. And finally, if you go to 12 ice cream cones, that should cost $21.24. So if we go ahead and draw a line here, this should work out nicely. And that would be our graph for our linear relationship over here. Okay. If you wanted to write a linear equation, you could for this. Not totally necessary, but you could say y, or the total cost, is equal to $1.77 per cone, or y is equal to 1.77 times x. Okay. So there's number 3. All right, let's check out number 4. So for number 4, what we're going to do here is we are going to use unit prices to compare the better value. We have $27 for 4 large pizzas, or we have $32 for 5 large pizzas. Then we have to determine how much would we save per pizza if we bought the better deal. Okay, so we have to use unit prices. So if you forget, unit prices just means that we're going to find it per one of something. So the first situation is going to be $27 for 4 pizzas. And if we want to find the unit price there, what we're going to do is divide by 4 and divide by 4. And so if we divide 4 by 4, we're just going to get 1 pizza. And I know 27 divided by 4 is going to be $6.75. If you weren't sure about that, you can use a calculator, or you should practice long division just to get a little bit of practice in for that. Okay. For the second scenario here, we have $32, but it's a little more expensive. We get 5 pizzas instead, though. Okay. So how do we find the unit price? We have to get it for 1 pizza. So we can go ahead and divide by 5. Divide by 5. $32 divided by 5, it should be $6.40, I believe. Okay, so what your job to do then is to compare these two prices. That's for 1 large pizza from the first place, and this is for 1 large pizza in the second place. So the second question says, how much would you save per pizza? Okay, well, you'd have to take the $6.75 and then subtract that, subtract the $6.40 from it. And if we do that, we're going to see that there is a 35 cents difference per pizza. So, well, it's only per 1 pizza. If you eat a lot of pizza across, a lot of weeks or months or years, you'll save some money between these 2 pizzas. Okay, so in terms of which one's the better deal, that's this one over here. The better deal is if you were to buy the 5 pizzas and spend the $32. Again, you get an extra pizza and you save a little bit of money per pizza. And for this final question 5 says, how many yards are 342 inches? Given a few bits of information here. So we have two conversion factors. Hopefully this one seems familiar, that there are 12 inches in 1 foot. And another one over here, we say 3 feet is equivalent to 1 yard. Okay, so we should be using dimensional analysis to solve these types of problems. And so what we do is we take the original value of 342 inches and we just write it over 1. Okay, if there's only one type of units to begin with, that's all we do. Following that, we're going to use multiplication, and we're just going to try to multiply by some identities here of 1, so multiplying by 1. So if we want to cross cancel, we're going to put 12 inches on bottom, which is the same thing as 1 foot on top. Again, so that's one conversion factor. Again, because 1 foot is really the same thing as 12 inches, the value of this conversion is really just 1. So we're not going to be changing the value of this answer. And then what we're going to do next is we are going to change this into yards, right? So we are going to put the 3 feet on bottom and the 1 yard on top. And I'll tell you why, again, in just a moment. Just bear with me here. I'm just writing this out here. So 3 feet is the same thing as 1 yard, so just writing on top of each other. Now, if you're wondering why I kind of organized everything the way I did, notice here that inches and inches are diagonal, and we can always cross-cancel units when we are multiplying, okay? And then we also see feet and feet are going to cross-cancel as well. Okay, so that's the purpose of putting the feet and the inches in these specific places, as well as the yards and feet as well. Okay, so what's left to multiply? 342 multiplied by 1 is still 342. Multiplied by 1 is still 342. So we're going to have a total of 342 yards on top as a numerator. And on bottom, we have 1 times 12, which is 12. Times 3, which is 36, and there's no units down there, so it's just going to be 36. Okay, at this point we have 342 yards, but it's divided by 36, right? So to figure out what this really is in yards, I'm going to go ahead and write this long division out just to give you a little bit of practice. I know earlier I was doing some in my head, but I just want to practice a little bit with you as well. And so 36 doesn't fit into 33, and it doesn't fit into 34, but it should fit into 342. Now, we know 36 times 10 is 360, so that's too much. So what's 36 times 9, right? And so 9 times 6 is 54, carry the 5. 9 times 3 is 27, plus the 5 is going to be 32. Okay, so we know 9 is how many times 36 fits into 342. 9 times 36 is 324. Kind of funny, those 42 and 24 are reversed. And then what's 342 minus the 324? That remainder should just be 18. And if you're not sure what to do, you really have two options right now. You could stop right here and write this quotient as 9 and 1836. And that's just equal to 9.5. But if you wanted to practice dividing decimals and you didn't want the remainder there, then put a decimal, add a 0, bring it down. Now you just keep going, but it's 9 point something, okay? So how many times does 36 go into 180? I'm going to get this on the first try just because I know what it is, but if you're not sure, it might take you a couple tries. 6 times 5 is 30. 3 times 5 is 15, plus 3 is 18. So that's going to be a 0.5. So 5 times 36 is 180. Oopsies, I'm going to move this down just a little bit. And if you subtract here, we're going to get a remainder of 0. And so hopefully this 9.5 here makes sense because that's the same thing as 9.5. So hopefully that was a little bit of quick review as well. But finally, our solution here is going to be, this is equal to 9.5 yards. Okay. So if you had 342 inches, that is equivalent or the same thing as 9.5 yards. All right, so there you have some explanations. Hopefully that cleared up any misunderstandings or helped strengthen some understandings of rates for you. So as always, keep up the great work, and I will see you in the next one.